Okay, Sawyer is asleep right now in that chair over there. And I'm gonna go right along here trying to find the roots S1 and S2, and they are minus alpha plus minus square root of alpha square minus omega square. This I did in my calculator, and because it's very painful, 15 10 to the 7 squared minus 20,000 squared, and then you take the square root, and it's like 150 times 10 to the 6, I think. I may be wrong. So let's see, S1, S2 is going to be minus alpha, which is minus 150, plus minus, oh, this one I have to really use 149.999 10 to the 6. 150 plus minus 149.999, all this 10 to the 6, because one of them is going to be almost 0 and the other one is going to be minus 300 10 to the 6, which is minus 3 10 to the 8, and S2 will be minus, like it's barely there, right? Minus, let me see, 150, minus, it's going to be minus 1.3. Let's see, I don't know why my, so then we write this out. So this here, we're interested in the current. IL of t will be minus 3, not minus 3, sorry, my bad. Let's try again. IL of t is K1 e to the minus 3 10 to the 8t. So this is going to be going to 0 pretty fast, plus K1 plus K2 e to the minus 1.3t amps. Now we need to use the initial conditions to find K1 and K2. So now I'm going to use 5a for I of 0. So I of 0 I know is 5. And then I substitute here for t equals 0. This goes to 0 to 1, and this goes to 1. So 5 will be K1 plus K2. The second equation is that the derivative of the current is at 0 is 10, or minus 10, sorry. And I'm going to do the derivative here. Oh man, it's going to be a pain. Minus 3 10 to the 8 K1 e to the minus 3 10 to the 8t, and then minus 1.3 K2 e to the minus 1.3t. And now again, I want to evaluate this at 0, which means these go to 1, the exponentials go to 1. So now I have simply minus 10 equals minus 3 10 to the 8 K1 minus 1.3 K2. That's a system of equations that I will not solve. 5 equals K1 plus K2. So I could write K2 is 5 minus K1. So I can go here and say minus 10 is 3 10 to the 8 K1 minus 1.3 times 5 minus K1. From here, I find K1, which is going to be K1 is going to tend to 0, right? Because whatever happens here, it's going to be divided by 3 to the 10, 3 times 10 to the 8. And then K2 is going to be almost 5. So I'm going to be approximate. Will be I of t, that was a really bad circuit that I made up, will be K1 is almost 0, so I'm going to leave this b, and I'm going to write almost 5 e to the minus 1.3t amps. It's really 2 terms, but the other term is going to go to 0 so fast, and it's multiplied by 0. That's not going to matter. So if I wanted to approximate the solution to the circuit, really, this is the most critical piece. I'll make a circuit that has a better solution to show you another video.